Welcome to Homework Lib.
The trig function models the position of a rung on a water wheel where t is measured in seconds and y is the feet above the water level. What is the diameter of the wheel? The diameter of the wheel is going to be related to the amplitude because the amplitude is the center. So the radius from this would be 20, which means that the diameter is 40 feet. At the top of the wheel, how high are we above the water? Well, if we think about this wheel, that plus 16 is the new midline. And then the amplitude is 20, so we go 20 below, which would be a -4, which is in the water, and as high as plus 20 to 16, and we get 36, so 36 feet high above the water level. How many rotations per minute does the wheel make? Well, if t is in seconds, then normally the period of sine is 2 pi, but notice we're multiplying pi over 6. So we have to divide that out. And dividing by pi over 6 is the same thing as multiplying by the reciprocal 6 over pi. The pi's would then cancel, and we get 12 seconds for the period. So how many that's one rotation. How many rotations per minute does the wheel make? Well, if there are 60 seconds in a minute and it rotates every 12 seconds, then it makes 5 revolutions in a minute. At the Bay of Fundy, the difference between high and low tide is 8 meters. No, we don't know what that is yet. So that would mean if the water level is 0, then it would go from -4 to 4 meters. If it's 8 meters, difference between high and low. And the period is 12. This would mean that the amplitude is 4. And if at midnight it's at high tide, that's at time 0. So that would be a cosine function. So we can say, if we're going to write a sine function here, that we would, if the period is 12, and we want to write a sine function specifically, we could think of this as a negative sine function, in that we would just want to actually, let's think of the sine as starting at 0, and we would want to just move this back. So we want a phase shift. That would be a quarter of the period. So if the period's 12, we would say the phase shift is 3. Well, -3 because we're going to move it backwards. So our sine function would be, I'll do h of t for the height of the tide after time t in hours, would be 4 sine. If the period is 12, and normally for sine it's 2 pi, we have to scale by pi over 6 on our time. And then we have a phase shift going back 3, so that would be actually +3 inside of the function. It'll take it back a quarter. And we don't have a vertical shift because the midline is at 0.